Okay, Assalamualaikum and very good morning to Dr. Peter Klapa and Dr. Go. Today we from Group 1 and we want to present to all of you about glucose oxidase. And I'm Syafiq and this is Luqman, this is Salam, this is Redzuan and this is Zulhilmi. Okay, now we can start our presentation. Okay, so for task 1, as you can see, glucose oxidase enzyme classification number is 1.134 and its synonym is beta-D-glucose oxidase and D-glucose oxidase, same as known as GOD. And the catalytic reaction from actually it start from here. It start from beta-D-glucose, and when beta-D-glucose react with oxygen and glucose oxidase will catalyze this reaction to become D-gluco-1,5-lactone plus hydrogen peroxide. Okay. Okay. Next is physical properties. As you know, the location for glucose oxidase is extracellular, that is cell wall, and outer cell membrane. Molecular mass is 160 kilodalton, 80 kilodalton for each subunit because it has 2 repeating unit. This dimer. Isolated point is 4.2. Heat stability, it is very stable between temperature 37 and 60, around 60 degree. And this dimer consists of 2 equal subunits. And each subunit contains 1 FAD, flavin adenine dinucleotide, and 1 iron. Cofactor is FAD, is Km is glucose oxidase is relatively specific for beta-D-glucose, and which Km is 33 to 110 millimole, and the substrate specificity is beta-D-glucose as we looked before. Okay, and this is another reaction. As you can see in the slide, it separates to reductive half reaction and oxidative half reaction, and to proton electron transfer in the oxidative half reaction. Enzyme is oxidase, and finally D-gluconolactone can be hydrolyzed non-enzymatically to gluconic acid. And next is similarities and differences in the organism. Glucose oxidase found commonly in Aspergillus and Penicillium. Part of glucose oxidase catalyze the oxidation of beta-D-glucose as we looked before. Same, and differences is glucose oxidase in Penicillium has higher affinity and specific constant, higher specific constant than Aspergillus niger, but however, glucose oxidase is in Penicillium sp is less stable, as you can see, less stable compared to glucose oxidase in Aspergillus niger. Okay, for task 2, the application and industrial market needs of glucose oxidase, you can use a determination of glucose as molecular diagnostic, medical and environmental, use in food industry. It is also typical enzyme assay for biochemistry in biosensor and nanotechnologies. Biosensor and nanotechnologies, the most important technology, biological approach, using biological approach, and also used in the textile industry. Okay, now move on to task 3. Thank you.
Okay, a very good morning to Dr. Go and Dr. Peter. So today I'll be presenting about task 3, which is about how we measure enzymatic activity of GOX. Well, firstly I will say I'm sorry if I cough a little because I'm feeling a bit under the weather. So firstly, about measuring enzymatic activity of GOX, we use DNS, which is 3,5-dinitrose salicylic acid assay, so that we can see the activity of GOX, firstly we add the GOX with the substrate, and then we would heat it at the optimum temperature and at optimum pH for a brief amount of time. Then we add the DNS region and we would boil it to 100 degrees Celsius. Next, we would place the mixture in an ice bath for a short moment, and then we would record the absorbance of the mixture. So why do we use DNS assay for to measure the activity of GOX? Is firstly because it's the most convenient, because it's a single continuous assay without any additional work, because there are two types of assay, which is continuous and discontinuous. So this one, you just do one assay to measure the activity of GOX. Next is the DNS assay. It reacts with reducing sugars. The DNS reacts with the aldehyde groups within the sugars, the substrates. So it would have a reaction. So lastly, it's easy to measure because when the oxidation process occurs, it forms 3-amino 5-nitrosalicylic acid, which absorbs light at 540 nanometers. Okay. Next is task 4, which is producing a cell extract from Aspergillus niger, which contains GOX. So to do this, we use pulverization using liquid nitrogen. So firstly we harvest the Aspergillus niger, and then we suspend it in a sodium citrate buffer. Then we add the liquid nitrogen, and after that, after the nitrogen evaporates, we would pulverize the biomass so that we can get the cell extract. So why do we use this method? One is the most reliable and inexpensive and efficient, because although there are other methods such as sonication and bead mill, but this one is the most the easiest and it's the cheapest. So usually we just use whatever we have. So next is the buffer. It's used to stabilize the target protein, which in this case we use the sodium citrate buffer. Then lastly, it's used to so that we avoid time and protein loss caused by additional buffer exchange, because sometimes when we use different kind of buffers, we have to use it, we have to exchange it, so it will take a lot of time, and then we will use a lot more proteins. Okay, next I will pass it to my colleague.
Hello and very good morning. Today I will present about protocol to produce purified glucose oxidase from Aspergillus niger. Okay, this is a step to produce the glucose oxidase. Okay, first enzyme fraction centrifuge as 9,000 gram in 10 minutes. Then protein was precipitated with ammonium sulfate at 4 degrees Celsius. Then centrifuge for 45 minutes. We can get a pellet suspend in 10 milliliter buffer. Then we continue with gel filtration. Sulfadates G100 was carried for salting out and extraction for GOS and GOS on the basis of molecular mass. Then we continue with fraction with maximum enzyme activity was pulled and further purified with Q sulfurose, DEAE sulfurose for weak anion exchange by ion exchange chromatography. Then protein was eluded with 500 milliliter linear gradient from 50 to 500 and ACl in 2 millimolar trace buffer in pH 7.2 at a flow rate of 2 milliliter per minute. Lastly, we can determine of protein and glucose oxidase. How we can determine it? Okay, this is a method to we determine glucose oxidase. Okay, we can know that there is a GOS by determination molecular weight and optimum temperature. Okay, for molecular weight determination, we can determine by use SDH pH in 12% acrylamide gels. Then in optimum temperature and pH, we can use some method to know that. GOA acid buffer was equilibrate for 10 minutes at different temperature. That is 15 to 40 degrees Celsius. And then pH produced profile for GOS was performed in different buffers system contain 50 millimolar concentration. And lastly, adjust to pH value of interest range from 4 to 8.5 pH. That's all for task 5. Next.
Okay, very good morning to Dr. Go and Professor Peter. I hope you are in a good shape. Okay, right now we'll continue with task 6. Okay, to demonstrate the purified protein is glucose oxidase. Alright. So, it's gonna be quick. Okay, the first we're gonna use sodium dialysis sulfate polyacrylamide gel electrophoresis or SES page. Okay, the purpose we use this SES page is to distinguish the protein bound carbohydrate or in the other name glycoprotein from the substrate from the mixture. Okay, next we're gonna dissociate the multimeric proteins and separate the peptides by molecular weight, and then we will get the protein bound carbohydrates. Okay, for the next method is we're gonna use protein and flavin assay. Okay, the purpose we use this protein and flavin assay is to differentiate the protein that we need, the demand protein. For this case, we need GOX, glucose oxidase. Alright. Okay, so for the next task is to demonstrate that there are no significant contaminants in the sample. Okay, it is a combination of two methods. The first one is ion exchange techniques. Okay, these techniques allow the separation of ions and polar molecules based on their affinity to the ion exchanger. Okay, in this case we know that the pH optimum for glucose oxidase is 4 to 5. So slight adjusting to the pH or the ionic concentration of the mobile phase, we will get the GOX, we will get glucose oxidase. And then the elution, by increasing the ionic strength of the mobile phase, is a more subtle effect, as the ions from the mobile phase will interact with the immobilized ions in preference over those on the stationary phase. And then shields the stationary phase from the protein, and it will allow the protein to elute. Okay, then separation can be achieved based on the national isoelectric point of the protein. Okay, the second method is by sieve chromatography. Okay, work based on material with very small holes and precise and uniform size. Okay, as my friend said earlier about the molecular size of GOX. Okay, its apparent native molecular weight is about 18 kilodaltons, while its denatured molecular weight is about 8 kilodaltons. So from the information we can get, it is easier for us to get GOX from the information we get, because we know the weight. So just slightly adjust our chromatography and we will get GOX. Okay, alright. continue task 7. Thank you.
Hello, good morning. So task 7 is about finding to investigate the 3D structure of GOX and identify the active site of this enzyme. So to investigate the 3D structure, we use bioinformatics tools, and for this task, we specified the tool of catalytic site atlas search, which is www.ebi.ac.uk. So in this website, you can just input the enzymes PDB ID or UniProt ID or EC number, and then just click search. For GOX, the UniProt ID was P13006. So, and the result is as you see. So that is the EC number. And this is the list of active sites of GOX, which, as you can see, there is histamine, glycine. So if you have watched the video Dr. Peter posted on how to find active site using bioinformatics tools, he compared between enzymes of different organisms, and then he find the similarity in the amino chain between those enzymes. So this website already do that to you when you click search. So no need to find out about other enzymes or from other organisms. This is the amino acid chain. And the 3D structure is supposed to be this part over here, but unfortunately there was a problem with the Java applet. So yeah, this is a 2D structure, but the 3D structure can be found on that website should you have correct and functional Java. Okay. So, and then task 8 is to find a method to analyze change in protein structure. The task was that So yeah, to analyze change in protein structure, you just use size exclusion chromatography. From before heating, the elution time would be, you will get an elution time, and then after heating, the elution time would be different. So there is change. Thank you very much.